This is the next video in the chapter on composition of solutions. We just talked about how to calculate molarity and how you can make a solution with a particular molarity by measuring out a solid on a balance and dissolving it in a certain amount of liquid. But not all solutes come as solids, some of them come as liquids. So our other method of making a solution with a particular molarity is called dilution. So dilution, as it sounds, is making a solution more dilute or less concentrated. And the way we make a solution more dilute is by adding more of the solvent, more of the larger piece. And in our case, our solvent is always going to be water. So we're going to dilute everything we make in the lab in general chemistry by adding water to it. And the thing that we usually do the dilution of is called a stock solution. So a stock solution is a very concentrated solution with a high molarity that we use for dilution. It will be diluted to a lower concentration. Usually when you buy chemical solutions from a vendor, from an industrial producer that makes these solutions, it comes in only one concentration, and that is the stock solution. And you might say to yourself, well, why doesn't it come in a bunch of different solutions? What if I want to make 0.1 molar? What if I want to make 0.5 molar or 3 or 5 or 7.72 molarity? Why doesn't it come in all of those bottles? And the answer is we don't have room for all of those bottles. No one does. We don't have room in the stock room for bottles of every concentration of every solution. There simply isn't space, and they wouldn't last long enough anyway. So instead, each solution usually has one particular concentration, the most concentrated version of it that it comes in, and that is the version that you buy from the store, and you dilute as needed to get the concentration that you want. In case you were wondering, this weird shape is supposed to be a bottle, specifically a 4-liter bottle. So if I want to make a sodium hydroxide solution, I am going to have to make it out of a 4-liter bottle of about 20 molar sodium hydroxide solution, which is very intense. Remember that I was trying to make, in the last problem, I was trying to make 0.225 molar solution, which is a factor of 100 less than that stock solution. So according to our definition of dilution, dilution is adding more solvent, in this case, adding more water. So your first idea might be, okay, well, we'll take the stock solution and we'll just add water, a whole bunch of it. We'll just keep adding water until we decrease the concentration enough that we get the molarity that we're looking for. But remember, we are trying to make a solution that is about 100 times less concentrated. So if we do that, oh, here, we'll add a handle, then it'll look like a bottle. So if we add enough water to this solution that we make it 100 times less concentrated, we are going to make almost 100 times as much solution as we started with. Specifically, this is going to make 356 liters of solution, and that is absolutely ridiculous. We don't need 356 liters of solution. We were only trying to make 100 milliliters in the last problem. So this is just not a good use of our solvent. We should not use all of it. So instead, we are just going to use some of it. So we are going to remove a small amount of it, and we are going to dilute that. instead. So this could be like our graduated cylinder with some little marks here, some graduations. We'll take out just a little bit, a few milliliters, and we'll dilute that instead. That way, when we take out just a little bit of the solution, we can make exactly the 100 milliliters that we were looking for. We can make 100 milliliters of 0.225 molar sodium hydroxide solution. So this way there's less waste. I don't have to dump 355 liters of solution that I don't need. And the best part is that most of this is left. Most of the stock solution is left so that other people can use it, because I am not the sole inhabitant of the chemistry department and other people need solutions as well. So we're just going to take a little bit of the stock solution out and dilute it by adding water. But of course, the obvious question is, how much? How much stock solution do I need to take out and dilute so that I can hit 100 milliliters right on the mark and get the molarity that I want? So there's going to be some calculation involved because we need to be careful. It's going to depend how much we need depending on how much volume we're trying to make, how much what molarity we're trying to make, and what molarity we started with is going to change the volume. But you see that there are sort of two concentrations of before and after concentration, and there's two volumes, the volume that we took out and the volume that we're trying to make. And that reminds me of the molarity formula. So our molarity formula was molarity equals number of moles over volume. And let's rearrange that because I know that I have both molarity and volume in this problem. So let's say I have molarity times volume, and that gives me a number of moles. Well, what good is the number of moles? Actually, a lot of good. So think about what happened during this step. When we took this little bit of stock solution and we diluted it, what happened to the moles of sodium hydroxide? They should be the same, right? All we did here was add water. All of the sodium hydroxide that was in this little bitty bit over here is still in this solution. It's just full of a lot more water as well. So in both of these cases, we have the same amount of sodium hydroxide. In other words, we have the same number of moles of sodium hydroxide. It didn't go anywhere. We just added water to it. And so with that knowledge, we can do something really sneaky. We can say, if the number of moles in that first situation over here, in our little bitty couple of milliliters in our graduated cylinder, if in this situation, our number of moles is equal to the stock solution molarity times the volume, whatever that small amount volume is, and then that number of moles is equal to the number of moles in the second situation, after the dilution, we can say that the molarity times the volume should also be equal to the molarity of the second solution times the volume of the second solution. So they're both equal to that same number of moles, and so we can relate the solutions to each other. So we call this equation M1V1 equals M2V2, or the dilution equation. And some textbooks call this C1V1. You might see it written like this as well. C is for concentration. So whichever version you wish to use is equally fine. So this is really cool. This is going to be a really useful formula. Just remember, the only time it counts as a dilution is when we take something and we add water to it. If we add some other solution with a different solute to it, if we do a reaction, if we heat it and that makes it bigger, that is not a dilution. We cannot use this formula. The only time we can use the dilution formula is when we are adding more solvent to a solution. So let's use it. Let's use it to figure out how much that small amount is that we need for this process. So in our first situation, we had a molarity of 20 moles per liter. That's how concentrated our super concentrated stock solution was. We don't know what that volume was that we had to take out. That's what we're trying to figure out. In our situation 2, our molarity was 0.225 moles per liter. And our volume was 100 milliliters. So let's put that in liters, 0.1000 liters. Okay, so our liters cancels and our moles cancels. So our volume is going to be in liters. That's what we want. And we can solve that pretty easily on our calculator. The volume is 0.001125 liters, or 1.125 milliliters. And that is a volume that I definitely have the glassware to measure. And again, let's specify which one it is, because I need to know which solution I'm talking about, the first solution or the second solution. So this is 1.125 milliliters of the 20 molar sodium hydroxide solution. Especially when you're writing in your lab notebook, it's important to be super clear about what you need to do, because sometimes you go into the laboratory and you're really sleepy and you don't remember what you're doing and you measure out the wrong thing. So not only do we need to include the number and the unit, but we also need to include what exactly we are measuring, what solution we need to measure, so that we grab the right bottle when we get there. In the next video, we will talk about how to physically do a dilution, and then we'll do a couple of example calculations using this formula.